Hello, everyone. We'll probably just give it another minute. Uh, Maybe I'll just start doing the intro. So today we're gonna have Fibo go over the some of the token changes, and I'll do like a little summary of the next steps. But Fibo's mostly going over what the changes are and yeah, that kind of thing. Yeah, I guess actually I think we're kind of at quorum, and this gets recorded anyway. So Fibo, you can take it away. You're ready.
Okay, thank you. I prepared some slides just to kind of like help to guide the discussion. Let me just share my screen. Oh, good. Okay, cool. So today I'm going to talk just about the work that we have been doing in terms of creating an efficient SPL token program. So this is not a new token program, but essentially a re-implementation of the existing SPL token program, so making it efficient. So the slides, I just have a few slides. The idea is just to go over kind of like why we start looking into this, what are the benefits, and how we achieved this efficiency, and a little bit of like how much more efficient we managed to get it, and a little bit of like what are the next steps that we need to do to eventually then replace the program. So the big question is like why we are looking to the token program. And if you look at the block compute units consumption, you're going to find out that about 10% is used by token program instructions. And this is a rough average that I just calculated over like the past 3 weeks. So some blocks have a little bit less, some blocks have a little bit more. But even if you look at further back than 3 weeks, is around there. It's like it's kind of like I saw between like almost 7% to 14% sort of that range. And if you look at even like specific instructions, if you look at a simple token transfer, you know that it takes like 4,600 CUs, just a simple token transfer, no delegates, no multi-sigs, and so on. So that's just a plain simple token transfer. And we know that it uses more CUs than it should. If you look at the code, you can see, okay, it shouldn't take that much CU for what it's doing. And by reducing CUs taken by the token program, we actually can create block space for more transactions. So if the token program uses less CUs, then all that kind of like free up CU capacity then can go to other transactions. And that's essentially is kind of like the main benefit of this, is actually kind of like making space for other things to happen than the token program. So just taking kind of like a quick math, if we can reduce the CUs taken by the token program by 1/20th, that 10% of block CU becomes 0.5%. So immediately now you have 9.5% of block space. And that's just kind of like that's the, as I said, the main benefit is that it's a very kind of like easy way to increase block space by changing the implementation for a more efficient one. And then there is also kind of like cascade improvements that we can achieve because if we improve the CUs of a token program, any program that kind of like is CPI into the token program, then the CUs automatically get reduced as well. So you improve composability and you make CPIs cheaper in terms of CUs because now it's kind of like, instead of taking like 4,000 and something, you can make it for 150 CUs, a call to a transfer, for instance. And as a kind of like a side effect as well of making an efficient implementation is then you can also reduce the program binary. So the binary size of the token program gets smaller. There is also kind of like opportunities to bring the withdraw excellence ports instruction from the token 22, which would allow to retrieve brick SOL from mint accounts. So for instance, the USDC mint had about 323 SOL in excess that could be retrieved if that instruction was available on the SPL token. And we can do also like planning to do the same sort of level of improvements to the associate token account program. And one thing that you can quickly notice on the ATA program is that there's a bunch of somewhat unnecessary log messages that we can reduce them, and immediately you can just save around 500 CUs just by reducing the amount of log messages that the program does, apart from the actual reimplementation in a more efficient way as well. But there is very easy, quick gains just by looking at how it's implemented. So how we have gone about doing this kind of like a reimplementation. So we started with a kind of like a like-for-like rewrite of the token program. So from scratch, we re-implemented the token program with the same instruction and account layout. So there is no changes there in terms of like it works with the same account layout, the same instruction layout, and it has the same behavior, meaning that if you give the same input, it gives back the same output. So if the errors are like have to be compatible at the same point, given the same input and so on. So it's a like for like reimplementation. And now the plan is to then replace the current SPL token program to be part of the Agave 2.2. And this will be done by a consensus breaking feature gate with the activation through validator governance, not a single contributor. And in terms of efficiency, how we actually achieve that, first of all, is the rewrite is a no STD implementation, so it doesn't use anything from the STD library, which avoids having to link the STD or parts of the STD library into the binary, so that shaves a good amount of bytes. The program binary went down from 106 to about 66 kilobytes, so not quite by half, but like about like 40%. Doesn't do any allocations, so everything is kind of like pre-allocated. Reduces the number of copies on the program. So every account access, even the instruction data access, is like 0 copy. So that's one thing that really gives a big gain in terms of CU usage, not having to copy the data back and forth. And I have here just a sample of the sort of improvements that we achieved. This is just like not all instructions are there on the repository. All instructions are there, but this is just here, just a sample of the sort of like main ones. And also these are like simple tests as well. It doesn't test the case of like a complex scenario with a multi-sig and things like that. But you can see here that, like, for instance, the transfer, which is one of the most used one, from 4,645, we managed to get it down to 153. So that is sort of like, it takes now 3 to 4% of the current amount of CU that the program has. And that's where kind of like all the gain basically that we managed to achieve in terms of like creating more block space is going to come from. So the big question obviously is how can we be confident that we can just like safely replace the implementation. So the first step that we have done is that we generated fixtures from the existing test suite that was part of the SPL token original implementation. Generating fixtures mean that you kind of like save all the input, the account data that use as input, the instruction data used as an input, and execute the instruction on the program, and then compares the output. So the output meaning the whole account state after the instruction was executed. And this is not just running a test and checking that the asserts pass, because essentially the comparison, the output, you are comparing the whole account state. So every single byte that you pass as an input is compared in the output, and they have to match. So even if your test was not asserting something and it was changing a value that it shouldn't, but because you're not asserting, it doesn't test. A fixture is going to test every single byte. So meaning that every single byte that you gave as an input, you record the output, and then you compare. And at this point, we have the implementation passing all our fixtures. Obviously, we're going to increase that kind of like coverage for the testing. We want to do some differential fuzzing and audits. That's sort of like a required step as well. And we can do more of the above until we are confident that we have kind of like a like for like implementation. And so that's kind of like the main sort of like overview of the work that we have been doing. I just leave the link here for the temporary home of this re-implementation. So everything is there, all the tests with the fixtures and everything, all the implementation is there. I have it here as well in a different tab if someone has specific questions about the kind of like the implementation and things like that. But yeah, I leave it open now for like questions and discussions.
I have a one. So you talked a lot about the CU impact. Is there any memory impact?
It should, well, yeah, definitely it should be better because it doesn't use any heap allocation. So it should be better on that as well. There's no heap allocation in the whole program.
Anybody can. Yeah, go ahead. Go ahead.
I don't know, I was just curious. You were talking about test fixtures and comparing the account states. We've done some very similar like tooling and fixtures and stuff for other programs. Are you using our infrastructure, like our frameworks, or is this an ANSA specific thing?
This is Mollusk, so I'm pretty sure there is
Got you. Okay.
maybe kind of like a combination.
Yeah. Cool. Sounds good.
Yeah.
Sorry,
I guess.
I just have a question. Are we targeting 2.2 for this, or how does the whole like governance um vote thing work? How do we get that in time for the 2.2 release cut?
I'm hoping that John is here in the call to help me out with the practicalities of this vote.
Yeah. So pretty much this will run similar to other votes that have happened. So it's not, we don't mean that we want to do it in time for 2.2. It means that the feature gate will go into version 2.2, and then it'll get enabled with other, well, it'll get enabled as part of the version 2.2 release following the governance process that we've done before.
Okay, cool.
Yeah, we did 2 governance votes last year. One was on Tommy vote credits. The other one, it escapes me immediately. But yeah, this is something we've kind of semi-productionized. There's a couple of people on this call who helped lead it, Tim and Ben, Tim Garcia, Ben Hawkins, who's, I believe, Ben's iPhone right now.
Yep.
Yeah. So yeah, we'll be leading it. Like basically the foundation kind of helps facilitate the vote, and then actually one of the votes last year wasn't even the time of vote credits. I don't even think we helped out much at all. So just kind of
Yeah, we did not.
We'll make sure it's facilitated if somebody else doesn't, but there'll be a governance vote on chain for sure.
Do you anticipate there being much like controversy around this, or do you think it would be a fairly easy vote?
Easy vote.
Probably easy vote. Just everybody wants more transactions, and so I mean so the next questions I think that will everybody ask is like about the auditing, especially just as long as those are published and there's confidence in those. This is there's no spec change here, so it really is just kind of like what the assessment of the risk of the audit, which kind of makes me like follow up with, is there plans of even doing like formal verification? Because I know we did formal verification of the um you know token 22 or token extensions, and then maybe as a follow-up to that question is, would there be plans to refreeze this account or refreeze this program after it was upgraded?
On that last front, I think my understanding, and John's, correct me if I'm wrong, or whoever, we are going to just like basically hot swap it. So it'll be just as frozen as the previous one, like requiring a similar process to change it if we want to do in the future.
Yeah,
Yeah,
that
that's
seems
correct.
great. Yeah, that was my understanding too. Just wanted to make sure it was on camera. Uh, and yeah, so that makes it a lot more palatable. I would say like once it was correctly audited and that it would not be made to be remutable. I think those things would probably make this pretty straightforward vote, but we'll see. It's obviously always up to the validators.
I expect it'll probably cause a large amount of discussion amongst devs, is the application developers, since so many of them depend on SPL token.
Yeah, will there be will there be a SIMD written for this change? Like, yeah, okay, cool.
There has to be. If there's not a current plan, there has to be.
Yeah.
Do we know
So
who was running point on writing the SIMD?
That's probably going to be me next week.
All right, cool. Looking forward to it.
yeah. Once you get that out, then we can assess the timeline on it from our side a little bit better.
Yeah, and I'll meet with you guys, or I mean, I'll just chat with you offline to figure out how we should when and how we should initiate the governance process. I think I can take point in helping making sure it happens.
Any other questions from the group? All right. Well, happy Friday, everyone. Yeah, we'll have another one next month. I know there's been a few kind of notable public's always interested in anything with economics. So there's inflation, like a fee, the change in the way that block rewards work. So that might be a topic for next session. But as always, if you have something that you want to present or are interested in, bringing on this call, just reach out to me or yeah.
I had a question. So
Oh yeah,
the multi-coin guys proposed an emissions change. Is
exactly.
that
That's
what
what I'm
the
referring.
biggest discussion? Okay, all right.
Yeah. That's yeah. I don't like calling it inflation because I actually don't I think that's an incorrect usage of the word inflation. I'll be putting out some uh hopefully some materials on the correct naming of these things. It's actually like emissions is the correct way of saying it. In block rewards, it's inflation actually typically deals with price. So inflation would be if the like priority fees kind of go up over time, or even the base fees. I know that Solana's base fees are not dynamic today. They probably eventually will be, but that would be an inflation. It would actually be the price. Inflation does in terms of price. Obviously, there's a correlation between like prices and the supply of whatever currency or token that is used, but they aren't the same thing. And the reason why it matters is inflation really is a measure of the costliness of using, interacting with an economy. And again, it's not necessarily like if I hold the currency of the thing, how much will I like expectation to use that same amount of token in the next week? So if I want to buy bread, it's $5. What confidence I have is that bread $5 next week. That is a measure like that measures kind of inflating and like in my ability to transact. It's yeah. So they're related, but it is not the same thing.
What's
But
the
anyway,
process? Either
yeah.
just taking that seriously or not taking it seriously, or
Yeah, it just takes, it's just one of those anybody can bring up like into the public, and for the SIMD process, it takes just multiple people from like, protocol devs, and then this one is an economic one, so it would also need to take to a governance vote. So
has anybody looked at the proposed layer 0 database for replacing RocksDB? Have you?
yes.
Okay, I just brought that up. That's way over my head, but I'm curious if anybody actually looked at that.
Yeah, my Brooks, we consulted Brooks about it. There might be some parts that we can use it for, but not as far as my understanding is not the core protocol itself. It might
Uh,
be helpful for like a layer two. Did somebody else have a point?
oh, yeah. Anybody have a comment on that? No.
I mean, yeah, RocksDB is a implementation detail of Agave, so it doesn't really affect the protocol.
Yeah.
Not in terms of the okay.
But yeah, so this would not, yeah, that would not be like a core protocol change. But my sense is that it actually is more beneficial if we wanted to just change out something with like a network extension or whatever you want to call it. Uh, it might be faster in terms of storing that like off-chain data and representing having a representation or a hash of it on chain. It seems to be more along the lines of that than it is. So the reason why, if for everybody in this room, Brooks is working on a new implementation of uh, the hash that goes in to certify the data. So the new implementation is a lattice hash, which is my understanding is that is incredibly efficient, way more efficient than even this implementation that Layer 0 put forward. So it doesn't really seem to add much. But that's my understanding of the situation.
There were some tweets last month about Solana SDK and Solana program separating. My understanding is that's not fully finalized, but that's coming. I don't know if this is the place to discuss messaging around that.
Yeah, that's a fine topic. Jacob, I think, has
Yeah,
some.
Rex, we can chat with that separate to this. I don't want to spend everybody's time here on that.
Later. All right, cool. Well, thanks. That's all I have. That's it.
Yeah, I think we're good. Yep. Yeah, Steve, you're right. Yeah, Lattice Hash is definitely a joint effort between multiple orgs, Anza, Fivedancer, a few other. Yeah, we're excited about that one. But I mean, the layer 0 stuff is cool. I just don't think it, as far as my understanding of it, is it wouldn't necessarily make it into the core protocol today. We might find some use for it. Maybe as we think about different like cold storage or whatever, different archival, chili peppers. There's other implementations that we've talked about with storage types. Maybe it would make it into that, but I don't think it would necessarily replace the lattice hash approach. All right. Happy Friday, everyone.